We're going to look at another form of the dot product. This is called the component form. So I'll just state it here first of all. A dot B is going to be A1 B1 plus A2 B2 plus A3 B3. So we'll see an example of that just below. So whenever we derived the dot product before, we seen it was going to be the length of A times the length of B times the cos of the angle in between. But we can also write it as this A1 B1 A2 B2 plus A3 B3. So that means that this here must equal that there. So the whole dot product now could be written as the length of A times the length of B cos theta is equal to A1 B1 plus A2 B2 plus A3 B3. Now it's not completely obvious why the dot product A dot B should be able to be written in that form. So I've put a little proof in the appendix section of the course notes, so you can go and have a look at that. It does use the cosine rule, which we've seen in the trigonometry section, but I didn't want to add it in here because I just thought it was going to clutter things up and it's going to take away from the flow of the course for the moment. So if you're interested, you can go and have a look at that derivation. But here's a simple example, and you can see that the actual examples are quite straightforward. So if we have a vector A, say it's 2, 3, 1, and vector B, which is 3, 4, 2, then the A dot B, we just take the A1 times the B1, so it's the first component of A1 times the first component of B1, so it would be 2 times 3, which gives us 6, and then it would be the second component with the second component, so it would be 3 times 4, which would give us 12, and then it would be the third component with the third component, so it would be 1 times 2, which is 2, and we simply add these together to give us a value of 20. So this is the final value for the dot product for these two vectors. So note as well from this here that we're able to find the angle between the two vectors if we know the components of the vectors. So let's say for example we had these two vectors here, so we could work out the length of vector A, we could work out the length of vector B. We also know the values A1 B1, A2 B2 and A3 B3. So we've got all of these and we've got the magnitudes as well. So it means that we'll be able to find the value of cos theta. So we'll look at that in the next video. Thank you for listening. Goodbye.